In this video, we're going to discuss a few aspects of inheritance that are quite handy and useful. And we're also going to look at how you learn about interfaces in the API guide. So to get started, I've gone back in my shape class and I've recompiled everything because I took that all out to make the zip file. And I'm going to go ahead and make a new class called flex.java. Ooh. Let me get rid of that. It's another version of it. Okay. First of all, we're going to use an array list. So I'm going to go ahead and import that. So we're going to put two methods in here. Okay, I'm going to make a main method. And we're just doing procedures here, so I'm not going to get hung up on objects, and it's going to take an array list of shape. All right, like so. And I'm going to make a third while I'm in here. Okay, shape S. All right. So here's what we're going to do. First of all, we saw last time that you can make an array list of shapes. Well, you can also use it as an argument in a function. And you'll see here that you get a certain flexibility that's kind of handy. So let's open up here and go array list AL is equal to new array list. And I better come back over here and say what kind of array list I want, or I'll get shrieked at by the compiler. Okay. Okay, you can add a circle. And we'll do this so it's relatively easy to make a sanity check. So I've just made this array list. And I'm going to go ahead and say system.out.println of total area AL. So what we're going to do in total area is compute the total area of the shapes inside. So I'm going to make an output variable to store my return value. Now in the collections for loop, you have this freedom. You can use an interface type. So for shape S in AL, out plus equals AL dot area. No, not AL dot area, S dot area. Let's get this straight. And now I'm going to close this off. And then on the next line here, I'm going to say return out. Okay. So what we've done is gone ahead and totaled all the areas of the shapes inside. And I'm going to put a return 0 in here to stub this in so that the thing will compile and we can check what we've done so far. Okay, so I'm going to go ahead and, whoops. An illegal start of expression usually is indicative of the fact that you're missing a curly brace, which I'll put here. Oh boy, the import police. Look at that. Okay. Okay, class. Oh, I have shapes instead of shape. All right, that's a, by the way, that's a common thing to do. Let's go down there and get rid of that. So you're seeing a few of the common mistakes that get made. Okay, we got 132.5 roughly. So a circle, its area is about 78. Now you add 48 plus 12, which is 60, to 78. You get about 138 and some. Okay, so let's make sure we're right here. This is oops, yeah, that's 48. This has an area of what? 6. So we got 54 plus 78, and that's about 132. So this passes the sanity test. You can whip out your calculator if you want to be a little more exact about that, but close enough here. Now I'm just going to make something silly here, just to illustrate that you can use an interface type variable as an argument to a function. In fact, this is often a desirable thing to do if you want to be able to pass in various types of related objects to a function. So here's what I'm going to make. I'm going to say return s.area plus s.diameter plus s.perimeter. And I'll come up here, and I'm just going to do this. I'm going to say system.out println. Okay, and I'm going to say silly of new triangle of 3, 4, 5. I didn't name it, so I'm just going to have to type it again. That's the tough life. So we're gonna check on silly here. We'll run a sanity check on it. Okay, I forgot my parentheses. Oh, yuck. So I'm going to fix that. Okay, let's do that again. Okay, it says 23. So let's talk about it. The perimeter, 3 plus 4 plus 5, is 12. The area is 6. And the diameter is the longest side, which is 5. And when you add those three numbers together, you get 23. So you can see some nice things about interfaces. You can make collections of interface type. You can also make arguments to functions of interface type, and they allow you to pass in a variety of slightly different objects that are all related to each other via the interface. And the fact that these all implement this interface means this code is going to make sense. It's guaranteed, because you have said there's going to be an area function, there's going to be a diameter function, there's going to be a primitive function, and the compiler will enforce this. It will make sure that everything is of the correct type. So now you've seen a couple of nice advantages to interfaces. Now let's talk about interfaces in the API guide, because that's important too. So let's go to string, because that's our most fundamental class. And let's click on it. If you want to know, first of all, the standard library is full of interfaces. There are many interfaces. And as you can see, all of the interfaces that are implemented by string are listed here. Now, one that's of a lot of importance to us is comparable. Let's look at it. Okay, comparable is an interface, and it takes a type parameter. Okay, so in our case, it's comparable of string. Well, let's see why it takes that type parameter. Because if we go down here, the method that is required, and only one method is required, and that method is called compare to. So if you want to know if a Java object is sortable, it must be implementing this interface. So for things like collections.sort to work, or for arrays.sort to work, the objects must implement this interface, because this is how the objects are compared. They're compared by this compare to method. You should take a look through here about comparable and see what the design contract is, because that's a very useful thing to be aware of. Are there other things that implement this interface? Okay, first of all, you can see there are sub-interfaces. These extend the interface comparable, and they're all listed here. And then here are all the classes that implement this interface. So there are familiar classes in here. String is in here. Ooh, let's go back, please. And if you look, you can see big integer is in there. Okay. You can see that byte is in there, and it compares in the obvious way because that's one of the wrapper classes. The numeric wrapper classes all implement comparable. Okay, including the class character. So there are lots of different classes in here that implement comparable. So the two things you always want to know are, one, if you're looking at a class, what interfaces does it implement? And it will tell you, if you go to a class, it'll tell you right at the top. It'll tell you what the implemented interfaces are, and you can go in and look at those. The other is if you have an interface and you want to know what classes implement it, the API guide will tell you. So if we go to comparable, back to comparable here, you can see there is a humongous list of things that implement this interface, because lots and lots and lots of things in computing are sortable. You'll often hear the phrase natural order referred to by documentation on sorting methods. And natural order means that you have implemented this interface. So now we know pretty much all we need to know for now about interfaces. We know that an interface is a contract, that you accept that contract with the implements keyword, that interfaces are types, and things that classes that implement an interface are subtypes. Classes and interfaces are both types. And the implements relationship is a subtype relationship. You know, if you have a given class, say we do something unfamiliar here, and I'm going to go ahead and type in something like linked list. Okay, we haven't talked about linked list. It's a different type of list. It's a different way of implementing a list. It tells you that it implements serializable, clonable, iterable, collection. That's interesting. Collection is an interface. Deck, list. And this is the most important one. List. List is an interface. And if you write a method that accepts an array list, you might as well write a method that accepts just a general list. And this is the interface that is the supertype of both linked list and array list and a whole variety of other things. And you can see right here, here's all the implementing classes. There's stack, vector, linked list, attribute list, array list. Tons of things implement that. So now you're pretty familiar with the whole business of interfaces. And next time, what I'm going to talk about is something called a functional interface. This is a special type of interface, and there is a very interesting type and somewhat complex type of type inference that goes on that allows you to very easily create objects that implement these interfaces without creating a class. But we'll leave that until next time.